Hello, my name is Narasimha Dontula and I'm with Multisorb's R&D group. Today I'd like to share with you some new developments come out of Multisorb's R&D as well as the Multisorb's operations team. This is in the area of oxygen scavenging technology and it's in the form of resin and we are calling it the Fresh Plus resin. Some of the highlights of the Fresh Plus resin are it's a concentrate which can be let down into any of the layers of the plastic packaging barrier, and doing that results in impregnating the plastic packaging barrier for built-in oxygen scavenging abilities. Once the packaging barrier has oxygen scavenging abilities, one can eliminate the free-floating scavengers in your container and also extend the shelf life invisibly. This helps the food manufacturer to reduce the use of preservatives as well as chemicals they add in the food to increase the shelf life. Lastly, it helps the product developers to create packaging formats and packaging sizes which they could not do when they were using the traditional form of oxygen scavenger. It enables operations to potentially increase productivity while minimizing the capital expenditure on dispensing equipment. And lastly, it helps the supply chain to reduce the number of materials ordered. Oxygen is very necessary for most life. It's also been found to be a major factor in degradation of food and beverages. This finding has been done over the past 50 years, and as a result of which, packaging has been designed to minimize the degradation of foods. The functions of the packaging are to prevent recontamination of food by enzymes and microorganisms, and also to design a barrier structure and control the headspace environment. The food manufacturers also carry out another process to extend the shelf life of food. They gas flush the headspace. Gas flushing is done either by nitrogen or by nitrogen and carbon dioxide and their mixtures. But there is always some residual oxygen which is left behind. And these residual oxygen reacts biochemically with food, affects the appearance, specifically the color, the texture, and also this results in a bad mouth feel and flavor and serves as an environment for aerobic microbial growth. The way oxygen reacts with food is it causes rancidity of the unsaturated fats, it results in darkening of fresh meat pigments, it causes skunking or flavor loss of beer and loss of vitamin C in beverages, and results in mold growth in meat snacks like jerky and loss of aroma in coffee. So the food manufacturers, besides gas flushing, they have done other things to control spoilage of food. The techniques they have used are use of antioxidants, oxygen interceptors, and oxygen absorbers. But most frequently, they have used those techniques in combination with oxygen scavengers. Oxygen scavengers as a technology has been commercialized for the past 4 decades. Most common oxygen scavenger technology is the use of ferrous compounds, that's iron-based compounds. These compounds are available in the form of sachets or in the form of labels. Multisorb is one of the vendors for this scavenging technology. Most recently, researchers at Multisorb have been investigating other techniques of incorporating these iron-based technology into resins, and this has resulted in the formation of the Fresh Plus resin product. So we have recently developed an iron-based oxygen scavenging resin Masterbatch, and we are calling it as Fresh Plus resin. This is a schematic representation of the manufacturing process we have used to develop the resin, where we combine the polymer resin along with iron and other additives, and it is introduced into a hopper of a mixing device like a twin screw extruder, which mixes all the melts and mixes all the components and forms pellets of Fresh Plus resin. we have made various Masterbatch resins, and they have been made in polyolefins like linear low density polyethylene, polypropylene, as well as EMA. We have also made small batches in polyester. After making these master batches, we have tested using procedures developed internally by the Multisorb Group for its oxygen scavenging efficacy. After doing that, we have investigated their performance in cast and blown film extrusion process as well as in injection molding. In the extrusion process, we have looked at monolayer as well as multilayer extrusion process. In the case of multilayer films, typically we think the processor would incorporate it in a sealant film. A typical sealant film is shown in the scanning electron micrograph. It's a 3-layer sealant film where the center core layer contains the oxygen scavenging master batch of Fresh Plus resin. As you see, the ion particles are well distributed within the center core layer. We have looked at various sealant films, and most recently we have developed a multi-layer linear low density polyethylene sealant film which have been laminated to vacuum metallize PET pouches and used for meat snacks at room temperature. Typically, meat snacks are packaged in vacuum metallized PET pouches and they are gas flushed, and after that an oxygen scavenger sachet is dispensed in it. Using this technology, we will not have to use the oxygen scavenger sachet. This graph shows the residual oxygen as a function of time after we package meat snacks of water activity of 0.8 in a 6x8 Fresh Plus film pouch. We have used two design variables. One is a medium percentage Fresh Plus in the sealant film and a high percentage Fresh Plus in a sealant film. And what we observe is, even at residual concentrations, starting residual concentrations of 6%, we have been able to reduce it to 0 within 6 days. Higher the concentration of Fresh Plus, faster is the rate at which the oxygen is reduced to 0. This graph shows you the variation of residual oxygen concentration as a function of time when we vary the headspace volume. As a food co-packer, you know a headspace volume can be varied by changing the amount of product in the pouch. And in both these cases, we observe that at medium percentage Fresh Plus in sealant film, we could reduce it to 0 in a short amount of time. Lower the headspace volume, the amount of time required to reduce it to 0 is shorter. So to summarize, Multisorb has developed oxygen scavenging master batches. The master batches have been let down to make oxygen scavenging sealant films, which in turn have been laminated and converted. We have evaluated in various different formats, from pouches to lidding film to flow wrap. And most recently, we have made master batches which are applicable in the area of retort applications. Thank you for your time. We would love to talk to you about how Fresh Plus can be used for your applications. We have technical data both in the monolayer format as well as in the multi-layer format at room temperature as well as refrigerated conditions. We'd love to partner with you on your applications. Thank you.